Hello, everyone. Thank you for attending the ARM Dev Summit. I'm Jason Andrews, and today I'm going to talk to you about machine learning on ARM Neoverse CPUs with TensorFlow and PyTorch. So, machine learning on ARM servers. For machine learning on servers, we rely on multiple open source projects to support ARM as a first-class citizen, and we want to add ARM-specific optimizations to get the best performance possible. So what I'm going to talk about today is how ARM and ecosystem partners are working to enable the key machine learning frameworks on ARM servers. Those include TensorFlow and PyTorch, and we're going to talk about those on the ARM Neoverse N1 and the Fujitsu A64FX. So in terms of the partners that we're working with, we have a partial list below. We're going to work with Linaro, Ampere, Amazon Web Services, and Fujitsu to make machine learning run well on ARM servers. So the two most common frameworks for ML on servers are TensorFlow and PyTorch. So if you want to learn more about TensorFlow, you can visit tensorflow.org. To learn more about PyTorch, please go to pytorch.org. Both of these frameworks have community-supported Python packages available for ARM64. TensorFlow has the additional benefit of having official support for the Raspberry Pi, which is ARC32. Both of the machine learning frameworks support multiple backends. Today we're going to provide some information on how TensorFlow works with the Eigen and 1DNN backends, both with OpenBlast, the ARM Performance Library, and the ARM Compute Library, as well as some information about PyTorch, how it's working with OpenBlast, ARM Performance Library, and in the future, 1DNN with the ARM Compute Library. So for on-CPU machine learning, our goal is to create an easy-to-use, high-performing ML inference solution so we can take advantage of all the CPU-specific features as they apply to machine learning. So our first goal in terms of ease of use is to provide you with Python packages which work well as container images so you can get up and running quickly. And we want to have ARM as a first-class citizen, a well-supported architecture in machine learning frameworks. We also support a variety of inference workloads, so you'll see lots of examples related to image classification, object detection, and more. Then we want to make use of the ARM architecture features, which give the best performance for ML-type workloads. So we'll see 8-bit integers, we'll see the bfloat16, 32-bit floating point. We're also starting to see now the SVE vector extensions, and SVE2 will be on the way soon. As well as in the future matrix multiplier extension. So all of the hardware features that go into the ARM architecture should be well used and well supported in the machine learning frameworks. And of course, we want all this on the latest ARM hardware. So today we will discuss about the ARM Neoverse N1 CPU, as well as future Neoverse CPUs, which will add more architecture features, and the Fujitsu A64FX. So here's a diagram of the TensorFlow software stack on ARM. You can see there's a couple different paths through it and ways it can be configured for ML inference. The first one is with Eigen. This is the default path. If you just build TensorFlow, most likely what you'll have is the Eigen implementation. Then we have 1DNN as a new implementation backend. We started with the TensorFlow 2.4 there to add the 1DNN support, which is with the ARM Performance Library via CBLAS. In the future, we will extend that 1DNN backend to add the ARM Compute Library, including support for Indate. So we'll go through some of these things and some of the libraries, what they mean and how they apply to machine learning. So if you're looking for TensorFlow and PyTorch on ARM, here are some ways to help get you started. So there are ARC64 nightly builds. So these are community-supported builds on GitHub. So if you go to the TensorFlow or the PyTorch area on GitHub, you can find links there to community-supported builds. We're also setting up now community-supported builds hosted by Linaro. So I don't have links for those yet, but they'll be coming in the very near future. So you can go to Linaro and get those community-supported builds. One thing which is probably most useful is going to be the Docker instructions. So in the ARM software GitHub area, we have the links below. In the tool solutions, there are Docker files and scripts which will explain how to build TensorFlow and PyTorch for ARM servers. And it'll have all the right libraries, compiler switches, all the recipe to make that by yourself. So if you're interested in how to build those frameworks and want to tune or change or do a different compiler, all of those things are possible by using those Docker recipes in the ARM GitHub area. And then finally on the bottom, we have a link to a blog in the ARM community. So this has more information about the two frameworks and where to find more information. So you can go to is.gd/armmlblog and you can find out more information there on how to get started. It'll point you in the direction of the right place in GitHub, as well as where to find images. So let's take a look at the TensorFlow by ARM CPU feature. So one of the current things we're working on this quarter is going to be TensorFlow with the 1DNN and the ARM compute library. So that'll give us complete support for the 32-bit floating point across the both eigen, the 1DNN with the ARM performance library, and the 1DNN with the ARM compute library. We're also working on the compute library addition to 1DNN for the int8, including the dot product instructions, which are part of the ARM architecture. And we'll also see this quarter the first implementation with SVE, which is coming, and that'll be with TensorFlow with the eigen backend. So you can use this table to kind of see what's available now, what's very close, all the ones listed as Q4 2020, and then the things that will be coming in the future. Okay, so in terms of the primitives for 1DNN, we have a little bit more information on that. So the first row is about the C++ reference design. So this is really the kind of golden reference, which is provided just for correctness. And then in the gem-based primitives, we started by using the ARM performance library, and I'll give a little bit more information about that library in the future slide. And then for the optimized primitives for ML, we move to the ARM compute library. I'll give a little more information on how we do that. Okay, so for those not familiar with the ARM compute library, I'll give a little bit of background on that. So this is a software library which came from computer vision originally and was extended for machine learning. It provides a collection of functions that work across both ARM CPUs and ARM GPUs, and it's targeted at image processing, computer vision, and machine learning. So one of the unique things about it is that it supports all of the Cortex-A CPUs, as well as the Mali GPUs for use with OpenCL, as well as the Ethos-N NPUs. So it's a common library which supports all of those ARM IPs, so you can do machine learning on those. It's also the foundation of the ARMNN software development kit. So this is providing for inference in embedded and mobile devices. So you can take a look at that if you're interested, and how you can use ARMNN to accelerate machine learning. And it can even be used to accelerate machine learning on ARM servers. So it's worth taking a look at the compute library and the ARMNN library if you are interested in machine learning. So a few different places you can go to do that. One is mlplatform.org. mlplatform.org is the community set up by Linaro for the Linaro Artificial Intelligence Initiative. So you can go there and get more information about the full stack of machine learning libraries on ARM. There's also an area where you can go to our developer website and get lots more information about machine learning. The compute library itself is hosted on GitHub. You can take a look there. And then the active development with the full community now is happening on mlplatform.org. So you can go there if you really want to participate in all of the open source development activities which are going on for the compute library. So let's have a little bit of a comparison now. So I mentioned two different libraries used as backends in TensorFlow and PyTorch. The one on the left is going to be the ARM performance library. The performance library really originates from the HPC world, so high performance computing. Because of that, it only supports the ARM v8a instruction set and 64-bit world of HPC. And it provides a lot of the implementations for the best performance on ARM for HPC. So it includes BLAS, LAPACK, FFT functions, other linear algebra things. So these are all commonly used in HPC workloads. And so the goal of the performance library is really to get the best performance from ARM hardware in HPC, and it's also very useful in servers. On the right side, we have the ARM compute library. So the compute library, as I mentioned, originates from computer vision. And it supports not only the ARM v8a in terms of 64-bit, but also ARM v7a. So you can use it in 32-bit applications. That makes it useful in embedded IoT edge computing, also can make use of the compute library. And it provides functionality for both the computer vision functions as well as the ML building blocks, so convolutional neural network building blocks, like your activations, convolutions, pooling, softmax layers, all those things are supported directly by the compute library with very well optimized functionality. So that's why we have two libraries, depending where they originated from, and then we work those into the machine learning frameworks to get the best performance in ML. So hopefully this gave you a short introduction into the world of ML on ARM servers. So we definitely would encourage you to try out those Docker recipes for TensorFlow and PyTorch on ARIX64. We have the community-supported builds for TensorFlow and PyTorch, as well as Docker containers you'll be able to find if you go to the links and read up on the references that I shared. That should get you up and running quickly, and at the same time, maybe give you a chance to dig into the process of how the frameworks are built and look into making your own improvements or moving that to your own development environment. I would also encourage everyone to learn about the ARM performance library and the ARM compute library. Those are excellent resources for any applications which are performance sensitive and can benefit from the type of functions which are in the libraries. As lots of work has gone into the tuning and the performance of those, it's very good to take advantage in your own applications. And then we are always interested to hear your feedback. So we'd love to hear about how you use the different libraries provided by ARM in machine learning or any other type of applications. Always great to get feedback on that, so feel free to let us know. And then last thing I have to get involved is I would recommend that you could look into the open source community on the ML inference. We've just recently opened a bi-weekly public meeting, so you can go to the link which is listed there, bit.ly arm-server-ml. And you could join the meeting and have a community of people who are working on ML at ARM. You can ask questions and hear the latest information about what's happening with machine learning on ARM servers. So I just want to thank everybody. Hopefully that short update was useful for you to get some references, some resources for machine learning on ARM. I would definitely encourage you to check out our developer website. That's developer.arm.com. And stay tuned as we make more improvements for machine learning on ARM servers. Thank you very much and enjoy the rest of the DevSummit.